Welcome to the class of Mechanics of Solids. I am Mahendra Gattu. I am Assistant Professor at Department of Civil Engineering, NIT, National Institute of Technology, Roorkee. So, in this course, we will be discussing about the introduction of the. So, this Mechanics of Solids is a core subject for civil, mechanical engineering, naval architecture. The medium of instruction of this course is English. The audience specifically consists of undergrad students or diploma students in civil engineering, mechanical engineering, naval architecture, and also planning and architecture. Now we'll go ahead and discuss why you need to have this course, why you need to take this course. So in engineering mechanics, which was a prerequisite for this course, we have dealt primarily with forces and motion associated with particles and rigid bodies. In this course, we'll go one step further by examining the stresses and strains inside real bodies. So we treat these bodies as deformable bodies. So we determine the stress and strains, and then we use the physical properties of the materials to relate the stress and the strains. And understanding of the behavior of material behavior is essential for the safe design of all types of structures, whether airplanes and antennas, buildings and bridges, machines and motors, or shapes and ships and spacecraft. So this mechanics of materials is a basic subject in all these engineering fields. So the career prospects, once you learn this course, in this course you'll build the skills to work as engineers involved in design and maintenance of civil infrastructure, aeroplanes, machines, factories, ships, and spacecrafts. The terminology learned in this course is useful to communicate with fellow engineers in workspace. So the knowledge gained is also needed to study advanced courses like structural analysis, soil mechanics, design of pavements, and also finite element method. So the course objectives is we define the concept of stress and strain in the relationship. We also determine the working stress method, safety factors, temperature stresses, and biaxial stresses in cylinders and spherical shells. Then we go ahead and understand the torsion behavior in shafts and also in helical springs. Then we analyze the beams under bending, that is frictional loads. So we find out what is a bending moment diagram, what is a shear force diagram, and how to determine the shear stresses and normal stresses in the beams. And then we go ahead and find the deflections due to the applied loads. Finally, we study the buckling of columns, and which comes under the broad topic of structural stability. So the outcomes of this course are is listed here. So we understand the first outcome, we understand material behavior under loads and the concept of stress and strain. We identify the stresses and enhance the strength of thin cylinders and shells by wire binding. We also analyze and design shafts and closed coiled helical springs. The students will be able to do this, and students will also be able to analyze beams under frictional loads, and finally they will be able to understand the concept of stability and buckling in columns. So the activities and assessments are given here. For internal assessment consists of quizzes which are conducted on Moodle for 20 points. We have a mini project which is of 15 points, assignments 10 points, and online forum discussions done on Moodle as 5 points. The external assessment, there will be a final exam of 50 points. So the minimum criteria for passing is 60% of the internal assessment, that is at least 30 marks should be scored in internal assessment, and only then the student will be able to take the final exam. And then the minimum passing grade is 50 points, which is a combination of internal plus external assessment. So I thank you all for listening to this course introduction video, and we will continue with the further classes in after the bye.